Okay, so today we're going to work on section 8.6, which is solving rational equations. Okay, so just to go over the basic steps. Step 1 is to find the LCD, and to do this you might have to factor first. Okay. Step 2 is to multiply each side of the equation by the LCD. And then by doing this, you should get rid of all the denominators. So then you will just solve for the remaining polynomial. Okay, so let's do some examples. Let's see, my coffee cup is making a shadow. All right, example 1. If I have 3 divided by x equals 4, I see that my LCD is just x. So I'm going to write this over 1 so that I can see it more clearly. And then I'm going to multiply both sides by x. And over here, x divided by x makes 1. So I am left with 1 times 3, or 3 equals 4x. Okay. And then I'm going to divide by 4, and I get 3/4 equals x. Now, when you just have a fraction equals a number or a fraction, you can use a shortcut.
This might answer your question. In Bothell,
Echo
it is
off.
06/01/2020.
I don't know why that happened. You can cross multiply. So I'm just gonna over here, or 3/x equals 4. Again, we can put that 1 there. So 3 times 1 equals 4 times x, which is 3 equals 4x, or 3/4 equals x. So we can see we get the same result. The danger in cross multiplication is when people don't understand why it works, they just start cross multiplying anytime they see fractions, and we can't do that. It only works when we have a fraction equals a fraction. That's the only time we cross multiply. And the reason it works is because you're basically multiplying x by both sides and canceling it out, and multiplying 1 by both sides and canceling it out. So what you're left with is just each denominator on the other side because of the canceling out process. So it's a shortcut of doing this. All right, let's try another one. Example 2. 3 divided by x plus 1 equals 9 divided by 4x plus 5. Again, we're going to find our least common denominator, our LCD. Sorry about that. So our LCD is, there's no common factors here. We can't factor either of these. So it's just x plus 1 times 4x plus 5. So I'm going to multiply both sides by x plus 1 times 4x plus 5 and x plus 1 times 4x plus 5. And then here the x plus 1s divide to make 1, so I'm left with, well, and then here the 4x plus 5s divide to make 1. So now I'm left with 3 times 4x plus 5 equals 9 times x plus 1. So you can see here that this result is the same as if I just cross multiplied 9 times x plus 1, 3 times 4x plus 5. But the reason, again, that it works is because really we're multiplying by both denominators, both sides. So we're using that property of equality, but it works out that these cancel and these cancel, so we're only left with the opposite denominators. That's why cross multiplication works. Okay. And then we're going to distribute, so I get 12x plus 15 equals 9x plus 9. And I will subtract 9x and subtract 15. And I get 3x equals -6. Divide, and I get x equals -2. Okay. The one thing I forgot to say, you always want to check your answer in both of your denominators to make sure that they're not going to make 0. So -2 plus 1 is -1, that works. And 4 times -2 is -8, plus 5 is -3, that's okay. So those are good answers, safe answers. Okay, and then example 3. -4 over x plus 3 equals 5 over x minus 3. Okay, so this time I'm going to use the shortcut. I'm just going to cross multiply. We understand that this is really multiplying by the LCD, but let's go ahead and use that shortcut. So I'm going to multiply -4 times x minus 3, and I'm going to multiply 5 times x plus 3. So I get -4x plus 12 equals 5x plus 15. And then I'm going to add 4x. And I'm going to subtract 15. So I get -3 equals 9x. Divide by 9. So I get x equals -1/3, right? -3/9 is -1/3. So there's my solution. Again, I'm going to check 1/3 plus 3 is not 0. Negative 1/3 plus 3 is not 0. And negative 1/3 minus 3 is not 0. So we're good. All right. Example 4. All right, so now we have 5 divided by x plus 7 divided by 4 equals negative 9 divided by x. Okay. So here's where we can see cross multiplication is not going to work because we have this addition here. So we can't just multiply. It doesn't work. So we have to find the least common denominator, which is the least multiple of all the factors represented in the denominator. So it's going to be 4x, right? If we have 4x, that's divisible by every piece in here. So I'm going to multiply both sides of the equation by 4x. Now this is different than expressions. When we were working with expressions without an equal sign, we had to multiply by 4x over 4x. We had to multiply by a version of 1. But now because we have the equal sign, we're using the property of equality. As long as we multiply on one side, we can multiply on the other side. So there's a little bit of a difference that you have to be careful of between expressions without the equal sign and equations with the equal sign. Okay, so when I multiply 4x times 5 over x, the x's cancel out, so I'm just left with 4 times 5 plus, when I multiply 4x times 7 divided by 4, the 4's cancel out, and I am left with 7x. And then on this side, when I multiply 4x times negative 9 over x, the x's divide to make 1, so I am left with negative 36. And then I have 20 plus 7x equals negative 36. Subtract 20 from both sides, so I have 7x equals negative 56. And then divide by 7, so I have x equals negative 8. Okay, and again, I always want to check my solution and make sure it's not going to make a 0 in the denominator. It's not, so we're good. All right, example 5. And please remember, you can always pause, go back and re-listen to one of these examples. I know it's different than being in class because you can't ask me questions directly, but use the video technology to your advantage. All right, so the next one, 1 minus 8 divided by x minus 5 equals 3 divided by x. All right, so I want to find my LCD again. So I have a denominator here and a denominator here. This minus means that I have to treat this whole thing as one chunk, so it's different than the x. So I need x times x minus 5. So I'm going to multiply this whole side of the equation times x minus 5, and this whole side times x minus 5. And then distribute. So this is just a 1, so it's going to be the whole x times x minus 5, and then minus here x minus 5 and x minus 5 cancel, so I'm left with 8x equals the x's divide to make 1, so it's 3 times x minus 5. Okay, and then I'm going to use distributive property, x squared minus 5x minus 8x equals 3x minus 15. And then I'm going to combine like terms, so x squared minus 13x equals 3x minus 15. And now I see I have a quadratic because this is squared, so I'm going to make this equal to 0. So I'm going to subtract 3x and I'm going to add 15 to both sides of the equation. So I get x squared minus 16x plus 15 equals 0. Oh, I'm off the screen. I'll pause and let you catch up. Oh, all right. You guys who help me in class know that that's nothing unusual. I'm always forgetting to adjust the screen. Okay. Let's see. Where was I? Oh yeah. Negative 16 and positive 15. So if this is positive and this is negative, these both have to be negative. And so it's going to be negative 15 and negative 1. So x minus 15 times x minus 1 equals 0. So x equals positive 15 and positive 1. Those are my two solutions. And then again, I want to go back and double check, especially when you have two solutions. Make sure that they both work. So 15 minus 5, that's not 0, that's safe, and 15, that's safe. And then 1 minus 5, not 0, so we're good. 1, not 0, so we're good. So both of these solutions work, which is good news. Okay. All right, let's do another one. There we go. Example 6. 6 divided by, oops, I'm not giving myself enough room there. 6 divided by x minus 3 equals 8x squared divided by x squared minus 9 minus 4x divided by x plus 3. Okay, so I see this right here is the difference between perfect squares, so I'm going to rewrite this factored. So now I can see that my LCD is going to be x minus 3, x plus 3, because that would be divisible by the x minus 3, by both of them, and by the x plus 3. Okay, so I'm going to multiply both sides of the equation by this whole thing. So times x plus 3 is 3, and then all of this times x plus 3 and x minus 3. All right, here, x minus 3 and x minus 3 divide to make 1 or cancel out. So I am left with a 6 times x plus 3. Here, this whole thing and this whole thing cancels out, so I am just left with 8x squared. And here, the x plus 3's cancel out, so I am left with the 4x from here and the x minus 3 from here. Okay, so now I'm going to distribute and simplify. So 6x plus 18 equals 8x squared minus 4x squared plus 12x. Combine like terms. So 6x plus 18 equals 4x squared plus 12x. And then again, I have this x squared, which means it's a quadratic. So I'm going to make it equal to 0 and factor, hopefully. So 0 equals 4x squared plus 6x minus 18. So I need two numbers that multiply to make negative 18 and add to make positive 6. And, oh, I just noticed something. Before I even do that, I noticed that all of these are divisible by 2. So I'm going to factor out a 2 first. And I also notice I have an a value. So when I do my diamond, I need to do the other way. So I have 3 here, and I have 2 times negative 9, which is negative 18 here. So two numbers that multiply to make negative 18 and add to make 3 are I'm blanking. Oh, 6 and 3. 6 and negative 3. Right? Yeah, okay. So then I've got my grouping. So 2 times 2x squared plus 6x minus 3x minus 9. There's my two groups. So 0 equals 2 times 2x times x plus 3 minus 3 times x plus 3. So 0 equals 2 times 2x minus 3 times x plus 3. Okay, so then x equals positive 3/2 and negative 3. So there's my two solutions. And then again, I'm going to check both of these in my original equation to make sure they both work. So 2/3 minus 3 is not 0. 2/3 squared minus 9, not 0. Sorry, 3/2. 3/2 plus 3, not 0. So this one works. And then negative 3 minus 3 works. Negative 3 squared is positive 9. Minus 9 is 0. And negative 3 plus 3, that's 0. So this does not work. So this is extraneous. And this is our real solution. Only 3/2 is our actual working solution. All right, last example. Nope, I'm wrong. That was it. That's all the examples. Okay, we're done.